In this lecture, we're going to talk about linear equations. To solve linear equations, we're going to conduct a series of procedures that result in equivalent equations until we get the variable by itself. Some of the procedures that we can use are, first, interchange two sides of the equation. So this means if we have the equation 3 equals x, we can rewrite it as x equals 3. The second possible procedure we can use is to simplify each side of the equation by combining like terms and eliminating parentheses and other such operations. So, for example, if we have the quantity x plus 2 plus 6 equals 3 times x plus 2, we can rewrite that as x plus 8 equals 3x plus 6, using the associative property on the left-hand side and the distributive property on the right-hand side. Another procedure that we can use that results in an equivalent equation is to add or subtract the same value on both sides of the equation. So, for example, if we have 3x minus 5 equals 4, we can add 5 to both sides of the equation, and that would give us 3x equals 9. The fourth possible procedure that we can do is we can multiply or divide both sides of the equation by the same non-zero value. For example, if we have 3x divided by x minus 1 equals 6 divided by x minus 1, we can multiply both sides of the equation by x minus 1, giving us 3x divided by x minus 1 times x minus 1 equals 6 divided by x minus 1 times x minus 1. And the last property that we're going to talk about, which we can use to form an equivalent equation, is the zero product property. The zero product property states that if the product of two factors is equal to 0, then one or both of the two factors must be equal to 0. So, for example, if we have x times x minus 3 is equal to 0, then that means that either x is equal to 0 or x minus 3 is equal to 0. So let's do an example where we're going to use equivalent equations to solve an equation. For this example, we want to solve 2x plus 9 is equal to 5x. We'll start by subtracting 9 from both sides of the equation. This gives us 2x is equal to 5x minus 9. Next, we want to get all of the terms that have x on the same side of the equation, so we'll subtract 5x from both sides. This gives us negative 3x equals negative 9. Finally, to get x by itself, we'll divide both sides of the equation by negative 3, and so the solution to this equation is x equals 3. Now let's talk about a general strategy for solving a linear equation. The first thing that you want to do is you want to list any restrictions you have on the unknown variable. For example, if your equation has denominators, you need to be sure that the denominator of the fraction cannot be equal to 0. After you've noted any restrictions on the unknown variable, the next thing you want to do, if needed, is multiply everything in the equation by the least common multiple of the denominators in order to clear fractions. Next, we remove parentheses and simplify both sides of the equation. Then, using addition and subtraction, we want to collect all terms with the variable on one side of the equation, and all of the terms that don't have the variable on the other side. Fifth step is we want to simplify both sides of the equation, and then solve for the unknown variable, usually using multiplication or division. Finally, once you have a solution, you want to plug it back into the equation and check to make sure that your solution is correct. Let's do an example. We have the equation 1/2 minus 1/3 p is equal to 4/3. We want to solve this equation for p. So if we go through the steps listed on the previous slide, the first step is to note any restrictions on the variable. We don't have any variables in denominators, so there are no restrictions for this problem. P could be any real number. The next thing we want to do is try to remove our fractions by multiplying by the least common multiple. So the denominators we have here are 2 and 3, which means that the least common multiple will be 6. We'll multiply the entire equation by the least common multiple of 6, so 6 times 1/2 minus 1/3 p equals 6 times 4/3, and we simplify which will give us 3 minus 2p, using the distributive property on the left-hand side, equals 8 on the right-hand side. Now we want to get all of the terms with the variable on one side of the equation and all of the constants on the other, so we'll subtract 3 from both sides of the equation. That gives us negative 2p equals 5. Finally, we want to solve for p, so we'll divide both sides of the equation by negative 2, and that gives us that p equals negative 5 halves. And the last thing that we want to do is we want to check our answer and make sure it's correct. So we plug negative 5 halves into the equation for p, which gives us 1/2 minus 1/3 times negative 5 halves equals 4/3. And we want to see if this is correct. So using order of operations, we'll begin by doing multiplication. Negative 1/3 times negative 5 halves gives us a positive 5/6. So we have 1/2 plus 5 over 6 equals 4 over 3. Next we'll do addition, but remember, in order to add fractions we need a common denominator, so we can rewrite 1/2 as 3 over 6, and now we'll add 3 over 6 plus 5 over 6, which gives us 8 over 6. So does 8 over 6 equal 4/3? Yes, it does. This means that our answer is verified. Next, we'll solve equations that lead to linear equations. For example, x times 1 plus 2x equals 2x minus 1 times x minus 2. This example doesn't have any fractions, so we can skip the first two steps of the general strategy, and we can go straight to the third step, which says to remove parentheses and simplify. So we will distribute on the left-hand side and use the FOIL method on the right-hand side, leading us to x plus 2x equals 2x squared minus 4x minus x plus 2. We can combine like terms on the right-hand side to give us x plus 2x squared equals 2x squared minus 5x plus 2. The next thing we want to do is try to get the x term by itself. So let's start by subtracting 2x squared from both sides of the equation. That leads us to x equals negative 5x plus 2. We'll then add 5x to both sides of the equation. That'll get all of our x's on the left-hand side and the constant on the right-hand side, which leads us to 6x equals 2. The final step to solve for x is to divide by 6, so we get x equals 2 divided by 6, which can be reduced to 1/3. So we get the solution x equals 1/3. For the sake of time, we won't check this solution, but you can plug it back into the example to check and make sure that it is true. Let's look at another example. This time we have w times 4 minus w squared equals 8 minus w cubed. I'd like for you to take a few minutes and try to work through this example and find an answer. Once you've worked through the example, then you can continue with the lecture. We begin by simplifying. Distributing on the left-hand side gives us 4w minus w cubed equals 8 minus w cubed. We add w cubed to both sides of the equation, which leads us to 4w equals 8. Finally, to solve for w, we'll divide both sides of the equation by 8, and we get w equals 2. Again, you can plug this into the original equation to check and make sure that the answer is correct. Here's another example. We want to solve the equation x divided by x squared minus 9 plus 4 divided by x plus 3 equals 3 divided by x squared minus 9. If we go through the steps of the general strategy presented previously in the lecture, the first thing we want to do is note any restrictions on our variable. So since we have x's in the denominator, we need to make sure that the denominator is not equal to 0. This means that x cannot equal 3 and x cannot equal negative 3, because those two values would give us zeros in the denominator. The next step is to multiply everything by the least common multiple. So in order to find the least common multiple of the denominators, we'll factor them out. So this gives us x divided by x plus 3 times x minus 3 plus 4 divided by x plus 3 equals 3 divided by x plus 3 times x minus 3. And so our least common multiple will be x minus 3 times x plus 3. Let's multiply that by everything in the equation. So, multiplying through by the least common multiple, we get x minus 3 times x plus 3 times x divided by x plus 3 times x minus 3, plus x minus 3 times x plus 3 times 4 divided by x plus 3 equals x minus 3 times x plus 3 times 3 divided by x plus 3 times x minus 3. The benefit of multiplying through by the least common multiple is you'll get a lot of terms that cancel out. So we can cancel out our common terms, which will leave us with x plus 4 times x minus 3 equals 3. We clear the parentheses using the distributive method to give us x plus 4x minus 12 equals 3. We can combine like terms on the left-hand side to give us 5x minus 12 equals 3, and now we want to separate and get all of our x terms on the left-hand side and the constant terms on the right-hand side. So we'll add 12 to both sides of the equation, giving us 5x equals 15. To solve for x, we'll divide both sides by 5, and that gives us x equals 3. So the solution to this problem would be x equals 3, except remember at the very beginning when we noted the restrictions, we said that x cannot equal 3 because that would give us a 0 in the denominator. So since we have a contradiction, there cannot be a solution. So x cannot equal 3, so there is no solution to this problem. Here's another example. Negative 4 divided by x plus 4 equals negative 3 divided by x plus 6. I'd like for you to pause the video and take a few moments and try to solve this for yourself. Once you've finished or get stuck, feel free to continue the lecture. Okay, the first thing we need to do is note that x cannot equal negative 4 or negative 6 because that would make the denominators equal to 0, and the least common multiple or least common denominator would be x plus 4 times x plus 6. We'll multiply everything by the least common multiple, x plus 4 times x plus 6, in order to clear the fractions. And we see that x plus 4 cancels on the left-hand side, leaving us with negative 4 times x plus 6, and the x plus 6's cancel on the right-hand side, leaving us with negative 3 times x plus 4. If we distribute on both sides of the equation, that gives us negative 4x minus 24 equals negative 3x minus 12. Now we want to get all x terms on one side of the equation and all constants on the other. So I'll add 24 to both sides of the equation, which gives us negative 4x equals negative 3x plus 12. Now we add 3x to both sides of the equation, which gives us negative x equals 12. Finally, to solve for x, we'll divide by negative 1, and we'll get that the solution is x equals negative 12.